Thank you. So I'm going to tell you about my research into de-wetting. But before I do that, let's have a little bit of context. How many of you have ever spilt something all over your desk? Most of you? I know I have, and it's usually coffee. And this normally gets a response a little bit like this, but there's some really interesting and complex physics happening here. This coffee spreading out over your desk is an example of what we call wetting. It's a liquid spreading out over a dry surface. De-wetting would be the reverse of this. It would be the coffee coming off of the desk, drying the surface along the way, and back into the cup. And while I've never seen that happen, you do actually see de-wetting happen every day. So when you have a shower, you're covered in a thin film of liquid water. And when you step out of this shower, you transfer this liquid film onto the floor. Now, if you take a close look at that liquid film that you transferred onto the floor, you'll notice that it isn't a homogeneous film. It's actually broken up into individual little puddles. It's actually de-wet from the surface. So, how do we study de-wetting? Because this is very hard. How do you study something that requires it to spread out before you can unspread it? So this is where my research fits in. So I use the technique of what's called dielectrowetting. So what it allows you to do is turn a surface which is hydrophobic, which is water-hating, into something which is hydrophilic, something that is water-loving. And we can do this repeatedly, all at the push of a button. But before I show you all of this little magic of what we can do, let's go back to talking about wetting for a second. So wetting of a droplet onto a surface always occurs as a series of spherical cap shapes. And for a very long time, it was thought that de-wetting would be just a time reverse of this process, something that happens very much in physics, time symmetry. If you go from one way, you surely have to come back the other way. So let's have a little look at what happens when we take our liquid film and we de-wet it from our surface. So I don't know about you, but that didn't look like a lot of spherical caps to me. So let's take some snapshots of that and we'll talk through it. So de-wetting of a liquid film back into a droplet actually occurs in two stages. It's not just a single spherical cap stage of the wetting. Initially, you have a liquid rim build up around the edge, the perimeter of your droplet. As it forms inwards and your de-wetting occurs at this constant velocity. And then, as these rims coalesce together, they form back into a spherical cap-shaped droplet, and this changes the actual speed of the de-wetting. Instead of being nice and constant, it now becomes what we call an exponential. So, while so far, in my research, I have shown that de-wetting is not a time reversal of wetting, the best way of getting that coffee back off of your surface is still just the humble paper towel. Thank you.
Thank you, Andrew. Thank you very much.